All right. So I want to show you guys how to run a full test by yourself, because you're going to have to do this, all right, potentially on the test in a couple weeks. All right. I was going to have a quiz on this at the end of the week, but I've decided, since 2/3 of the class will be gone for the retreat, that I'm going to give the girls and the boys this quiz this week, and you can look at it if you want. You don't have to do it. Okay. So you can do it on your own or not. Okay. So let's start by looking at this problem. We have, yes, you're back. Excellent. We're looking at an investigation into the presence of bacteria in packages of chicken sold in supermarkets. Exciting stuff, right? Wait for it. We're actually going to focus on brand name Purdue, not Tyson. All right, it's okay. Brand name, if you want to make it Tyson in your thing, that's fine. Purdue, so brand name, compared to store brand, so like a Kroger, H-E-B, store brand, okay? So they went to different stores in different cities, and they found 33% of the 75 name brand packages had contaminated chicken, and 45%, these are not real, 45% of the 75 store brand contained contamination. And we want to know, is there a difference, right? Should we tell consumers that you should really pay more money for the name brand because you get sick less? Okay? So that's what we're going to find out. So you'll notice I already wrote, all right, this down for you? You're so welcome. So what I've already done for you is I have defined the parameter. And now this time, you'll notice there are two parameters.
So it's basically double the word.
Well, okay, hold on. Let's not like get our listeners, subscribers, sad out there in the real world. But no, it's not double the work. Right now, okay, yes, yes, it's double the work because we have two parameters instead of one. Fine. But you're going to see with the rest of the work, it's going to be maybe 10% more. Okay? 10% more. Not bad. Okay? And I've already done this for you, so you're welcome. So here are the parameters. I'm going to use P sub P. All right, so P sub P to represent the proportion of all Purdue chicken packages that are contaminated. Okay? Then I'm going to use P sub SP for store brand, the proportion of store brand chicken packages that contain contamination. So, hypotheses. Now, I already told you that the null hypothesis is we're going to say that they are no different from each other. Okay, now watch how I write this. Okay, watch how I write this. I'm going to write P sub P minus P sub SP equals, and if they're no different, what happens when you subtract two things that are no different? You get 0. Now, if you don't like that way, and that's fine, you could also change colors. You could also write this as P sub P equals P sub SP. I will take both. Okay, so either one you want to write is fine. You'll see later on when I do my mechanics why my brain has chosen to do the subtraction. Yeah, well, because I want your brain to know that we're always really doing subtraction. We're always subtracting these two numbers. Okay, now for the alternative, all right, what I always tell students every year is to copy P sub P minus P sub SP and the 0. The only thing that's going to change is they're going to be greater than, less than, or not equal to. Now let's pause for a second. What are we trying to prove here? What are we trying to prove? That the brand name is safer. Okay? Which means if it's safer, then the proportion for the Purdue one or the brand name should be lower. Right? Because if it's safer, it has a lower rate of contamination. So if this number is lower than this proportion, when you subtract, you get a number that's less than 0 or negative. So you're going to use a less than symbol. And if you wanted to do the other way, change back to red, you could write P sub P is less than P sub SP. I'll take both. Okay? Everyone okay so far? All right, so not double the work, Gareth. That was the same one. Pretty good? Okay. Now, after your hypotheses, now we're ready for the model. Okay? So, What's the first assumption I'm going to make? The independence assumption. Oh man, write small. Right, and I'm going to go ahead and play the cheat card. I'm the teacher, so I'm not going to. No. I'm going to say it. I'm going to say it. So you can closed caption me. Okay? Thank you, YouTube. Okay. Independence assumption. All right? Now I have to do this for both groups. Okay? So I'm going to write two statements. All right? You already wrote something? Bianca, what do you got?
She said she wants to be.
Oh, man, we haven't even started. Okay, so for the first statement, I'm going to start with the Purdue chicken, all right, the name brand. All right, so I'm going to say that if I find a package of Purdue chicken that contains contamination, it will not affect the next package of Purdue chicken. Listen. Yeah.
So whenever you're writing the like independence assumption, since you have to make it twice,
Mhm.
both groups, basically, can you write them together or yours is like?
Your choice. I'm going to write them together. But if you want to do them separately, if it helps your brain to separate, go for it. But you got to do it. You got to do both. Well, we'll take all points if you don't do both. Oh, don't worry. Plenty of space. I will repeat it. All right. I'm basically saying that if I look, right, if you imagine I'm holding a package of Purdue chicken, okay, and you tell me that this tested and it contains bacteria, okay, so it's contaminated, that will not affect the next package of chicken that I open.
So we put, if I look at one package,
If I find a package for.
If you find a contaminated package, it will not affect another package. You can just say that each chicken package is independent of other chicken packages. All right? And you can say that for Purdue and for store brand. If you want to choose a store, you go to Kroger, Randall's, H-E-B, go for it. All right? If you don't want to, just say store brand. All right? So for that one, I would say each store brand package of chicken is independent of the next store brand package of chicken. The key thing is I'm looking for both sentences. One about Purdue, one about store brand. Are we really going back to that? One more sentence? Guys, college is going to be tough. Future. Future problems? Yeah, future David problems. Fair enough. All right. It's okay. You don't worry about messing up. Just the practice one. All right. Now, once we make that assumption, what conditions are we going to check? You can do any order you want, Charlize, but I'm going to do randomization, condition, and the 10% condition. All right, and I will allow you here, all right, to combine them in one sentence. Okay? So randomization condition, does it say anything about randomly selecting these chicken packages? It doesn't. So I need to state that each group of 75 packages is a good representation of all of our chicken packages. Yeah, absolutely. We're saying that for the randomization condition, because it doesn't mention anything about randomization, right? And the problem we're hoping it says a random sample. It doesn't. So we need to write that each group is a good representation of all the chicken packages. So something to that effect. It doesn't need to be exactly that. And just think back to what we did 2 weeks ago. You guys have done this, all right, with one proportion. Say it again, Edgar. Each group is a good representation of all chicken packages. Right? Because basically, Edgar, I don't know how they're doing this. It says they went to, what, 25 cities? But once they got to the cities, how did they decide what stores to go to?
or which cities,
Or which cities? Good point.
or if they're on Nebraska.
Fair enough. It doesn't say, it does say U.S. though. So I'm assuming they're going to multiple states, but you're right, I don't know. Right? So I would want to know, David, where they're going. Right? That matters. Totally matters. Okay, now, the 10% condition. What's the sample size for both of these groups? 75. So if you multiply it by 10, what happens when you multiply it by 10? 750. So we need to make sure that there are more than 750 chicken packages for both of these groups. Now, do we think that there are more than 750 chicken packages? Yeah, absolutely. All right, it's probably 750 just in one store. Maybe not. A couple stores. Lots of chicken.
That's why I got contaminated.
Too many packages of chicken? You never know. Okay, so that statement again is that as long as there are more than 750 packages of chicken, our sample sizes are not too big. As long as there are more than 750 chicken packages, our sample size is not too big. All right, now, believe it or not, pretty much all of that was review. You've already done all that.
What size is the two?
You're right, the two sentences, fair enough. But now, there's a new assumption. The independent groups assumption. Now, this is just one sentence. All right? This is just one sentence to claim independence for your groups. We're saying that the chicken packages in these groups are independent of each other. Okay? The chicken packages in these groups are independent of each other. So there's no crossover. So I'm talking about everything from distribution, packaging, everything. Warehousing, independent. No crossover. So we're saying here that the chicken packages from both groups are independent of each other. Not done yet. But, take a quick break. Shake it out. Okay, let's move to our last assumption. The sample size assumption. The sample size assumption. Now this one, all right, you're going to make a statement. And what is that statement?
Certain sizes.
Very good. All right, and to make it so it's applicable to both, say that 75 for both groups is a large enough sample. All right, 75 packages is a large enough sample for both groups. Make sure you mention something about both of them being large enough. 75 packages is a large enough sample for both groups.
So what if it was like 75 and 95?
Great. So you would say 75 and 95 are large enough for these groups.
Sometimes the end won't be the same.
Correct. They don't have to be the same. All right, and this one it is. Good question. Now, this last one, we're so close, guys. And then we'll do the math. Success, failure, condition. Now, this one is a little bit new, all right, because you have to do n times p and n times q for both groups, okay? So I'll show you the work here. So I'm going to do n sub p, Sorry, I just wanted to do 2. You're right, you don't need 2. No, I'll just put p for Purdue. I'm just trying to have fun. Okay. Times p sub p. And then n sub p times q sub p. And do the same thing for your store brand. All right, so that's going to be 75 times, what is this one? I think it was for Purdue, was it 0.33?
It is
0.33, great. And then for the Q hat, it'd be 0.67. And then for this one, was it 45?
Yes.
Okay, and this one then is 55. All right, so make sure those numbers are 10 or higher. And if they are 10 or higher, then you know your sample size is large enough.
Yeah, they are.
Excellent.
If it's not, then we just stop right there.
Honestly, right?
There'll always be.
Great question, right? I think of it in two ways, Saul. Number one, if I'm doing a test and my teacher has given me a problem and I've got all this space to show my work, and I find one of them is 9, I'm not just going to close up shop and be like, you know what? It's not 10. Sorry, not doing it. All right. I would make a note to my teacher. This one is not 9, so I'm worried that my sample size is not large enough, but I'm going to keep going. All right. Hey, basically, give me the credit for keeping the work going. Okay. Now, if this is a real, out there, then go get more.
So how do
You
I, work with both all,
Oh man,
success values or?
I got you.
um,
Did I even put this on there?
Yes, you can.
See, look at me, right? Only for you guys.
Always looking out for us.
Always. All right, so that's what I expect to see. The conditions have been satisfied, so I'm going to use a normal model to run a 2 proportion z-test for the difference in proportions. Doesn't need to be word for word, something like that. What's up? Okay, we ready for the mechanics? Ready for the math? No. Well, don't worry. Less than 30 minutes left in school. We're almost there. So let's write down our formula. And you know what? I lied. Let's not do that yet. Let's write down our sample size for both of these. So we got sample size for Purdue and Store Brand are both 75. Then let's write down our number of successes. So letter X.
XP and XP?
Yes, correct. So we're saying, basically, I know it sounds weird, but a success here is contaminated chicken in your package. Okay? Now, for the last one, that's P hat for Purdue and P hat for Store Brand. Now, I think they gave us those, right? If you go back to the original problem, they gave us those P hats. They said 0.33 and 0.45, right? So to find the number of successes, you actually already did that. You just multiply the 75 times 0.33. All right, so how many packages were contaminated? Right, 24.75? You want to round up?
It's hard.
Yes,
You can round up if you want.
it's because like, you know how you said it? Yeah.
No, you're right. Say it.
Oh no, she said it.
Say it again.
It was in a packet.
You can't be part of a package, so let's round up.
25?
25, right? Because I bet if you did that, you'd get your 0.3 repeating.
Yeah. So 25 or 50.
Well, wait. Remember, this is for
I didn't know.
times 0.45?
Oh.
Yeah, so make sure you multiply. That would be the failures for Purdue.
34.
So did you round?
Yeah.
Yes, student. We multiplied 75 times 0.33, all right? Because that's the number of packages times the success rate to get successes. And we rounded, all right? Yes. Now, for the second one, make sure in your calculator, I always do this to check, in your calculator, do 34 over 75. Do 34 over 75. What do you get? All right, you should get 0.45. I mean, obviously, it's going to be a little different. You get 0.45, then the 3 is repeating. Then hit that button. Yeah, so you got 45. So you just always want to confirm that when you're using it this way, that you have the percentages correct. Okay, so let's write down our formula. our formula is going to be z equals, okay, p hat sub p minus p hat sub sb minus 0 over the standard deviation of p hat sub p minus p hat sub sb. It is minus 0, right? Because we're always saying for this one, Leslie, that we always think the difference
Zero.
is 0. Okay? Now, when we do this denominator, if you think back to 20 minutes ago when I showed you the formula, we have to use something new.
Variance,
We need that. Well, we'll do that. But even in there, Jarvis, we have to use a pooled p hat. Okay? So we need to pool them together. So let's do that over here. I use blue for the pool. Okay. All right. So this is p hat pooled. All right. So how many did we find were contaminated in the Purdue packages? 25. How many in the store brand? So I'm going to do 25 plus 34 in the numerator. And in the denominator, how many total are there? 75 plus 75. So 150. So if you do that division, it will give you our p hat pooled. Let's see what that is. 0.39. Okay, that's a step that sometimes it takes students a little while to understand, that you always have to do that pooled p hat.
What is that for? Like,
It's going to be in our standard deviation, because in the standard deviation, we're assuming that there's no difference. If you think back, to what we did 2 weeks ago, remember what we subtracted here was p, okay? It was p hat minus p, and that was always in the denominator. So that it's kind of, that doesn't happen here, but the idea is if there's no change, they're the same, then we have to think that they're the same. Okay? All right, so here we go. You ready? Z equals 0.33 minus 0.45 minus 0. And if you want to stop writing the minus 0, go for it. Over the square root of our pooled p hat. So then what's going to be our pooled q hat? If we take this away from 1, 0.61. What's our sample size for the first group? 75 plus, this is the variances add part, 0.39 times 0.61 over 75.
why is it,
Can't just do it like that, because if you do that, you're going to mess up the numbers. Question?
why is it the same as the pool?
So it will always be the same because we're pooling it. So these should always link. Now they won't always be the same for confidence intervals, all right? Because confidence intervals where you're going to think they're different.
But the end, what if the end's different than those two won't be the same?
Like the.
Good question. So in this case, we have the same sample size, but we'd already kind of talked about what if they have different sample sizes. Yes, you would write, if the first group had been 50 packages, then I'm writing 50 under here. Okay? So yes, the sample sizes could be different. But the numerators will not be, correct, because I'm getting that from the pool. All right? A lot of nuance here. Okay, so now I'm going to go to the internet. Okay, so if you have your phone, all right, you take that out. If you don't have your phone, I'm not going to bring the Chromebooks in because it's real fast, but I'll have them for later on in the week. So if you want to go to your phone, I sent you an email. I sent you 2 emails. But you want to do the one that says, go to my email here, says, to proportion z-test online calculator. All right, so to proportion z-test online calculator. That's the one you want to go to. Okay? It is Math Cracker again. Okay, so for the null hypothesis, we're always going to choose equals. Okay? Now what about for the alternative? What symbol did we use? Less than. Okay? What is our sample size in group 1? 75. Sample size in group 2? 75. Okay, favorable cases. So this is the number of successes. What did we calculate for the Purdue ones? 25? What's up?
I don't get the website.
You went to I sent 2 emails. Go to the first one. So you want the one, there was 2 emails today. Go to the one that's earlier. To proportion. There you go. You guys find it? Okay, I'll pause. I'll wait.
Okay.
They're both math crackers, but this one is for the test, not the interval. The same what? It's up to you. I mean, I'm going to use whatever you guys want me to use. Most students will just continue to use 0.05, totally fine. Personally, I might use something lower here because we're talking about people's health. Right now, I want to be more confident in my decision, so I probably make it tougher to reject, right? And we're talking about telling people to stop buying food because we think it's contaminated, so that's a big deal, right? Obviously, I don't work for any type of health administration, but you'd hope they have a very tough bar, right, to say that there's something going on. Otherwise, you have this hysteria when it's not actually happening. Okay? Now, for the store brand, I believe it was 34. Okay, so with that being said, do you guys want to keep using the same alpha, or do you want to use a different alpha? 0.05? Sounds good. Yeah, don't refinance your home loan. Okay. Everybody ready? So I know it looks like a lot, but it was only 7 things to type in.
Yep.
All right? Okay. So, yeah, so we'll take some time. Remember, you just watched the ad from Mike Bloomberg.
It's
gonna take a little bit of time, Randy. It's too-
Double the time because it's 2 proportions. You know it, man.
I like mine.
Come on, math cracker. Crack that math.
Let's go with
Hard
mine.
math. Can't crack it.
It's going to happen. Sorry. Come on, math cracker. Okay. Did it come for you?
Yeah.
Oh man, I'm jealous. Yeah, what's the Z-score?
One negative
Negative
1.504.
1.504. Okay. So there's our Z-score. Did it crack it? Did you crack it? Nope. Still waiting. Sad. All right. So I'm going to go to a new slide. I'm going to draw my curve. Remember that curve? So here's the curve. Okay, so negative 1.5, somewhere over here, z equals negative 1.5. And which way am I shading? To the left, right? Less than? All right, so those of you that it's cracked the math, what does it say your p-value is? 0.066 is what I heard? 2? Okay, I'm just going to stop at 6. Okay? So, you'll notice in your notes already, you'll see that this p-value is above our alpha of 0.05. So because our p-value is above alpha, we do not have enough evidence to reject the null hypothesis. So we're basically saying that right now, we think that the contamination levels in these 2 types of chicken packages are the same. Now, one thing I would notice, right, is my p-value, even though it's not below alpha, is pretty close. All right, so what would I want to do from here? So we're talking about people's health. What would I check again? Maybe more packages. Talking about going to 25 cities. Why do they only look at 75 packages? Let's test thousands of packages. Okay? If we got all the time and money, let's do it. then we'll be more confident when we do this again. Exactly, right? We don't want people to become sick. Okay? Any questions about this? Did my math cracker come? Come on, cracker. Come on, math cracker. Oh, man.
Yeah.
Oh. Man. What a disappointment. We crashed the server. Oh, that's so disappointing. Well, sorry for those people watching